Hello friends and welcome to our next class on Vedic Math, and this class will be learning about altered remainders and how to use altered remainder. An altered remainder is used to avoid the negative remainder alpha. Altered remainder is, let's suppose if we are dividing 35 by 8, we know that we can divide 8 by 4 times. 4 times is 32 and we are left with the remainder 3. Now how about if we reduce this number? If we divide 35 by, if we reduce the quotient from 4 to 3, then we'll be adding an 8 to our 3 in our on our remainder side. And likewise, in our quotient side, if we have reduced the number by 1, then on the remainder side we are adding our divisor to our remainder. That means we'll be adding 8 by 3. And likewise, we'll be gradually reducing the number of questions by 1, and we'll be keep on adding remainders by 1. Now the technique, so with this reducing number we can reach up to 0, and then we are finally left with the remainder completely as it is. So the altered remainder is applicable when we are getting a negative remainder. Let's take an example to understand it more clearly. So let's take this problem, 601325 by 76. We will write it in our format as we were doing in our previous classes. Okay, now if we divide 60 by 7, the most nearest number that comes out to be is 7. 8 times is 56, and we are left with the remainder 4. So we carry out that 4, and we know that 41 minus 48 is 6 times 8. We got 48. We are getting our answer as minus 8. So this is, to overcome this problem, we will be applying our altered remainder technique. What do we do is, over here is, we reduce the value of quotient by 1 and we add the number of dividend to our remainder. So our quotient is 7. We are left with 60 minus 49 is 11, and we will be writing it over here. So 111 minus 42, where 42 is 7 times, it comes out to be 69, and when we divide with 69 by 7, then we are left with quotient as 9, remainder as 6. Let's move on. 63 minus 6 times 9, that is 54, which comes out to be 9, and 9 by 7 is, quotient is 1 and remainder is 2. Now 22 minus 6, which comes out to be 16, and 16 by 7 is, quotient is 2 and remainder is 2. Then similarly, the next step is 25 minus 12, that comes out to be 13, and 13 by 7, 1, quotient is 1 and our remainder would be 6. So in similar fashion, we subtract and we divide, likewise we carry out over here as well. The only problem that we were getting was how to tackle the negative. So in order to do that, we step back with our quotient term and we add that number of dividend to our remainder. So now to carry on our division, we would add a 0, and now 60 minus 6 is 54. 54 by 7 is, we get quotient as 7. 7 times 49, and remainder is 5. So likewise, so the final answer that we got over here is 7912.17. So let's take another example, that is 695432 divided by 57. We will be dividing 6 by 5, so we get our quotient as 1 and remainder as 1. Now the next step is, now we will subtract 19 with 7, that is 19 minus 7, it comes out to be 12, and 12 by 5 we get quotient as 2 and remainder as 2. Then we will quotient as 2 and remainder as 2. Then we will again follow the same step, that is subtract 25 minus 14, since 7 2 times is 14, so it comes out to be 11, and 11 by 5, quotient is 2 and remainder is 1. So 2 and 1 are 14. 14 minus 14, it comes out to be 0, and 0 by 5 is quotient is 0 and remainder is also 0. Okay, then comes 0 by 3 minus 7 times 0, which is 0. So 3 by 5, which is nothing. Quotient is 0 and remainder is 3. Now comes 32. 32 minus 7. 32 minus 7 times 0 is 0. So 32 by 5 is quotient of 6 and remainder as 2, and we add more 0 to carry over division. And now if we see 20 minus 6 times 7 is 42. So we are getting over here negative. So again we'll be applying our altered remainder technique. In that we'll be reducing our quotient by 1. So this is what we have done. We have divided 32 by 5 and we kept quotient as 5 and remainder as 7. So we have reduced our quotient by 1 and we have added the value of dividend to our remainder, that is 7. Now we can go ahead with the problem. 70 minus 35, which comes out to be 35, and 35 by 5 is quotient is 7 and remainder is 0. It's very pretty clear. So when we write this, quotient 7, remainder is 0, and we again add 0 to solve our problem. Okay, now it's I think we need to again recheck our question. Since we are getting 0 0 and 0 0 minus 7 times 7, that is 42. So we are again getting our answer as negative. Again we'll be applying altered remainder and we'll be reducing our value by 1. So if we make it 6, quotient is 6, then we get our remainder as 5. And then we can add one more 0. And we see 50 minus 50, 42, it comes out to be 8. And 8 by 5 is quotient we get is 1 and remainder is 3. So likewise we'll be solving this problem. So the final answer is 12200.561. So these are the few more questions that I hope now you can solve by yourself by applying these techniques. And I've also written the answers below so that you can rest assured yourself that you're going in a right direction. Let's take another problem. 7458 by 127. So we can write this problem by either way. Either we can use it, we can write 12 below and 7 above, or 1 below and 27 above. So if we go with the second case, that is 1 below and 27 above, then I think it would take more time, because dividing it by 1 would not affect it much and it will keep on increasing our steps. So rather we'll write 12 below and 7 above. In the next problem we'll consider cases with 2 digit on top. Okay, now so 74 by 12, that is 12 6 times is 72. So we are left with 2, and we know 25 minus 42, since 7 6 times is 42, we are getting our negative answer. So we'll again reduce our question by 1, and when we do that, then we are left with 14 as a remainder. So 145 minus 35, which comes out to be 1110, and 1110 by 12 is 9 and 2 as a remainder. Now if you see closely, we are getting 28. Since 2 is our remainder, we'll be writing it on above. So 2 into 8 minus 7 times 5 is 35. So 28 minus 35, we will be getting again a negative answer. So we'll be again reducing our question by 1. So we'll be writing question as 8, and we'll be writing remainder as 14. So 148. So 148 minus 56 is 92, and 92 by 12 is question is 7 and remainder is 8. We'll add one more 0 on top to carry forward our division. Now we are left with 80. 80 minus 49, it comes out to be 31, and 31 by 12 we get question as 2 and remainder as 7. So we write it question as 2 and remainder as 7, and we add 0 one more. So likewise we stop over here. So our final answer that we get over here is 58.72. Let's take another different type of example. Okay, in this example we'll be considering a 2 digit on top. So as our rule, we'll be leaving 2 digits of our dividend and then placing a decimal. Okay, now we will be dividing 70 by 8, which comes out to be 8 as a quotient and 6 as remainder. Okay, now our conventional way of dividing and subtracting would not work over here. Earlier what we used to do is we used to take 63 and we'll subtract it with the 23 times 8, but this would be wrong in this case. Now since we are having two digits on top, the difference would be is we'll be doing a cross multiplication. So we'll writing 2 3 and 0 8 below, then we get the answer as 16. So 63 minus 16, which we get is 47, and then we'll be dividing 47 by 8. We get quotient as 5 and remainder is 7. Okay, quotient 5 and remainder 7. Now we're left with 71. 71, now we are having two digits on both the side. So 71 minus 5 times 2 plus 2 times plus 3 times 8. So you can see over here, for better understanding, I've done a cross multiplication and I've added them. So 5 times 2 is 10 and 3 plus 8 is 24. Total comes out to be 34. 71 minus 34 is 37, and 37 by 8 is, we get quotient as 4 and remainder is 5. Quotient 4, remainder 5. Now 59. 4 times 2 plus 3 times 5. So 59 minus 23, which comes out to be 36, and 36 by 8 is, we get quotient as 4 and remainder as 4. Now again 48. So 48 minus 4 times 2 plus 3 times 4, which comes out to be 28, and 28 by 8, quotient is 3 and remainder is 4. 45. 45 minus 3 times 2 plus 3 times 4, which comes out to be 27. 27 by 8 is quotient equal to 3 and remainder equal to 3. We add 1 more 0 and we stop over here. 8544.33 is the answer. So friends, you might be a bit confused and you might feel that this method is a bit complex one, but believe me, this is one of the fastest method that you can go about it, and of course practice is must for it. As you keep on practicing more and more, it will be easy for you to solve it mentally. I've again added some more sums, and of course now you are eligible to solve any problem. Just remember the techniques that I have taught you. So that's all for this class. Thank you.